Hello everybody, the topic of this tutorial is decimals. I am Lamide. After watching this video, it's expected that you should be able to simplify expressions involving decimals by performing basic arithmetic operations of addition, subtraction, multiplication and division, and also expressing decimal numbers to a specified number of decimal places. Now, let's have a look at some important definitions. A decimal number. A decimal number is obtained when the numerator of a fraction is divided by the denominator. If we divide the numerator of the fraction by the denominator, we convert the fraction into a decimal part. As if you can remember from the previous video, you have a fraction when you have a number which is called the numerator divided by the denominator. So now, but in fractions, you do not simplify further. But now, to get a decimal number, you divide the fraction. You divide the numerator by the denominator to get a decimal. So for example, 21 over 4 is a fraction. So when you divide the 21 divided by 4, when you have 21 divided by 4, you have 5.25. So you pronounce it as 5.25, not 5.25, because this 25 is less than 1. So a decimal number normally comprises a whole number. It comprises a whole number that can be 0 and above. So the 5 here is the whole number. It can be 0 and above, and the decimal part, which is less than 1. So here this 25 is not 25 because it's less than 1. So this is the decimal part of the number. So the decimal point separates the whole number, which is 5, from the decimal part, which is 0.25. so the whole number part is 5 while the decimal number is 0.25. so the decimal point here separates the whole number from the decimal part. So the decimal part of the decimal number can be thought of as a series of fractions, with the denominator being 10 for the first decimal place, to the right of the separator, the decimal point, 100 for the second decimal place, 1000 for the third, and so on. So for instance, when you have 10.357, so you can interpret it as the 1 you have tens, the 0 you have units. So that means you can say this one is 1 times 10, then this is 0 times 1 because it's a unit. Then here is tenth, which is 1 over 10 of 3, so you have 3 over 10. So this first digit, as explained in the previous slide, you have the denominator being 10 for the first digit, so you have 10 here. Then the denominator of the second digit after the decimal point is 100, so you have 5 over 100, and the third, you have the denominator as 1000, so you have 7 over 1000. So when you add 10 to 1 to when you add 10 and 0 and 3 over 10, 5 over 100 and 7 over 1000, so you arrive at 10.357 as shown here. So you have 1 times 10 because this one represents tens, while the 0 represents units, so you have 0 times 1. While 3, you have 3 over 10 plus 5 over 100, so the second digit after the decimal point will have a denominator of 100, while the third will have a denominator of 1000. So you have 10 plus 0, 0 times 1 is 0, plus 3 over 10, which is 0.3, then 5 over 100 is 0.05, and 7 over 1000 is 0.007. So when you add everything together, you arrive at 10.357. So any fractional value smaller than 1/10 will have the number 0 in the first decimal place. So here, this 0.05 is less than 0.1. So as you can see, here is greater than 0.1, so you don't have 0 after the decimal point. So here you have 0 after decimal point. This is the first decimal place. So the position of a digit after the decimal point. So the first digit after the decimal point is the first decimal place, the second after the decimal point is the second decimal place, and so on. So when in the first decimal place, when you have 0, it shows that the fractional value is smaller than 0.1. So here you see 0.05 is less than 0.1, and also any fractional value smaller than 100 will have zeros in the first and second decimal place. So 0.007 is less than 1 over 100, which is 0.01. So 0.007 is less than 0.01. So as a result, you have 0 in the first decimal place and 0 in the second decimal place before you have 7. So 1 over 4 is 0.25. So 1 over 4 is greater than 0.1. So can you see the first decimal place you have 2, and 0.25 is greater than 0.1. So now, addition and subtraction of decimals. So the key point with the addition and subtraction is to line up the numbers using the decimal point. So let's have an example to make this point clear. When you are to add 2.67 to 11.2, you can simplify by simply lining up the two numbers using the decimal point. So you have the points here. So here you have 2.67. Then can you see the points are aligning, and you have 11.2. So here we've added 0. So in order to make it easy to simplify, so 11.20 is the same as 11.2. So now let me show you on the calculator 11.20. So you still have your 11.2. So when you line up the two now, so you can then add from the left here, from the right hand side here, sorry. So you add 7 to 0, you have 7, and 6 and 2 you have 8, and you now put the decimal point because all these digits are less than 1. All the digits after the decimal point are less than 1. So now you now add 2 to 1, you have 3, and then you have 1. So you have 13.87. Let's have another example. So if you are to add 127.5 to 0.127, so 127.5 plus 0.127, so we align the two numbers using the decimal point. So when you by so doing, so you need to add 3, you add 2 zeros to this 5, to the right of 5, to make it have 3 places after the decimal, so that for easy simplification. So now you start adding from the right here. So you have 7 plus 0 is 7, 2 plus 0 is 2, 1 plus 5 is 6. Then you insert the decimal point, then 7 plus 0 is 7, then 12, you bring it down, there's nothing to add to it. So you have 127.627. so you can confirm that with your calculator. So another example, 14.73 minus 12.157. So to simplify this, you align the two numbers using their decimal points, and you need to add 0 to the right of 14.73 in order to express it to 3 places after decimal. So now you can then subtract. So 157, so if you subtract 157 plus 7 from 730, you have 573. So you have 0.573. so we'll put 573 here, then you insert the decimal point. So when you subtract 12 from 14, you have 2, so you have 2.573. So multiplication of decimals. So I haven't gone through addition and subtraction of decimals, so the next thing is how to multiply decimal numbers. So multiplying, the procedure for multiplying decimal numbers, the procedures are multiplying as if decimal points were not there, and calculating how many numbers are to the right of the decimal point in both the original numbers, and then finally placing the decimal point in your answer so that there are this number of digits to the right of your decimal point. So let's have an example. Calculate 2.1 times 1.2. So the first thing you have to do is to multiply the two numbers ignoring the decimal point. So you have 21 times 12, so you have 252. And now you now calculate how many numbers are to the right of the decimal point in both the original numbers. So here to the right of decimal point you have one number, a single number. Here you also have a single number, so you have two numbers, two digits after the decimal point in both numbers. So now you can then make sure you have two digits after the decimal point here too. So you simply place a decimal point here at this point. So you have so you can simply, this 252 is like 252.0, so you can simply move the decimal point here, so you have 2.52. So there is one number to the right of the decimal point as explained in each of the original numbers, making a total of 2. This has been explained. So 2.1 times 1.2 is 2.52. So you have to know this. Always look at the number at your answer to see that it's sensible. For instance, 2.1 is very close to 2 and 1.2 is very close to 1. So 2 times 1 is 2. That means your answer should be around 2. So if you have 20, or if you arrive at 20 or 0.2, that means you've made some mistakes. So you anytime you perform multiplication on decimals, you need to examine the answer and see whether it is sensible. So you can multiply the numbers that are very close to the 2, just as we've done here, and you know, for you to confirm by looking at your answer, compare whether it's right or your answer is wrong. So let's have another example. 1.4 times 6. So the first thing we multiply ignoring the decimal point here. So you have 14 times 6 is 4. And then now you have only one digit after the decimal point here, and this one has no decimal part. So you simply make sure this 84, you have one number after the decimal point, so you place it here. So as you can see, so you have 8.4. So you now have one digit after the decimal point. So to check, 1.4 is close to 1 and 6. So if you multiply, you have 6. So this implies the answer should be around 6. So if you have 0.6 or 60, it means your answer is wrong. So 6 is close to 0.8. So 6 is close to 8.4. So that's how you check anytime you evaluate multiplication of decimals. So now division of decimals. When dividing decimals involves the following step. The first thing is to write your numbers as a fraction. Then you move the decimal point to the same number of places to the right in both the numerators and the denominator. And then the third is you stop moving the decimal point when both numerator and the denominator are no longer decimals. And the last, you simplify. So 0.1 divided by 400. So the first point here, write a number as a fraction. So to write it as a fraction, so moving decimal point the same number of places. So when you move the decimal point the first place, you have 1 here. That means here is 400.0. so you can if you move the decimal point by one place, so you have 4,000. So you have 1.0 divided by 4,000. So 1 divided by 4,000 is 0.0025. You can confirm with your calculator. So let's have an example to make it clear. 0.32 divided by 0.08. So the first step, you move the decimal point to the right, 1 here, so you move here too. So you have 3.2 here at the numerator, and you have 0.8 at the denominator. You still move the second time. So here, when you move here, you have 32.0, and here you have 8.0. So 32 over 8 now. So you have the HCF, the highest common factor of 32, and 8 to be 8. So you have 4. So 32 divided by 8 is 4, because you have 8 in 8, you have 1, and 8 divided by 32, you have 4. So after simplifying, you have 4. So another example, 0.24 divided by 0.008. So you move the decimal point to the right. First time you have 2.4, and the denominator you have 0.08. So you have 2.4 divided by 0.08. Then moving the second time, you have 24, and here you have 0.8. So 24 divided by 0.8, when you still move this, meanwhile the 24 is 24.0. So when you move the decimal point once more, you have 240.0, and here you have 8. So now 240 divided by 8, you have 8 in 8, you have 1, and 8 in 24, you have 3. So you have 30. So 240 divided by 8 is 30. So now decimal places. The number of figures to the right of the decimal point is called places of decimal. So expressing a value to a specified number of decimal places implies something about the precision of the measured value. So when you express a value to a specified number of decimal places, it implies something about the precision of the measured value. Take for instance, when you have 1/3, which is 0.0. So when you have a value of 0.3333, so if you express it to two decimal places, you can have 0.33. I'll explain it later. So when you have 0.33, and you know that 0.33 is not the real number, it's not the decimal number you are considering. So you, by so doing, you've introduced some errors into your calculation. So the 0.33 will be to two decimal places. Meanwhile, the value, the accurate value, the correct exact value of the of what you are of the number you are trying to get is 0.333. So but and this series, the number continues, it continues recurring. So in order to make simplifying using this number easy, so you can simply ignore some other numbers to the right. So by so doing, you won't have the number you are working with, but you have an approximated value of it. So that deals with precision, how close the value you have is to the exact value. So now let's have an example. 3.556 has how many decimal places? So 3.556 has 3 places of decimal, because the decimal place is the number of digits you have to the right of the decimal point. So you have here, you have 3. This is your first one, this is the first, this is the second, and this is the third. So you have 3 numbers after the decimal point. So you have 3.556 is it has been expressed to 3 decimal places. So where the decimal result of this calculation does not yield an exact value, the result will normally be expressed as a certain number of decimal places. So to round the number to a particular number of decimal places, this does not mean that you should move the decimal point. You leave the decimal point where it is, but get rid of some numbers from the end. So as shown here, the result here is not an exact value. So in order to get to make the value exact, you can ignore some of the digits to the right. And when you ignore some of the digits to the right, so you get rid of the numbers from the end here. So you can have it as 0.33. So to make simplification using the number easy. So and you should know that you've left the decimal point where it is, but you actually read the number of some digits from the right. So to express the number to a specified number of decimal places, these are the procedures. One, you identify the last digit that is needed in the rounded form. So the second, you examine the next digit to the right. And the third, if the next digit is 5, 6, 7, 8, or 9, so you round the last figure before the cutoff by 1. And if the next digit is 0, 1, 2, 3, 4, or 4, then you leave the last digit. And the illustration below may be helpful. So when you have 0, 1, 2, 3, or 4, after the last digit you need in the rounded form, you let the number the last digit remain the same. But you have 5, 6, 7, 8, or 9 after the last digit. That means you add 1, you increase the value of the last figure before the cutoff by 1. So you may be asked to express a certain number or to a certain number of decimal places, or you may need to decide for yourself. As in the case of 1/3, you might decide to use 0.333. So in that case, you now have to state that 0.333 is expressing your 1/3 to 3 places of decimal. So just like that. So when you have, so for another example, when you have 4.936, so when it has been expressed to 3 decimal places, so you just state that the result, maybe when you are calculating and you come you arrive at 4.9, you arrive at the number and you've rounded it, you've corrected it to 3 places of decimal. So when you write it, then when you write the number, you state the number of decimal places that you've expressed it. So now let's have some examples to get the concept. Round 15.748 to 2 decimal places. So the solution, it means you have 2 digits after the decimal point. So now, as you can see here, we need 2 numbers after the decimal point. So you start, this is the first number, 7, the second number is 2. So now we want to remove any other number after this 4. And if you remember, so we now consider the next number, which is 8. So 8 is above 5. Remember the illustration. If the next digit is 5 and above, then you round up. So 8 is greater than 5, so you just add 1 to this 4 to make it 5. You round 4 by 1, so making 5. So you have 15.75. So as you can see, decimal point remain in its position, whereas the last digit has is only the last digit that has been rounded up by 1, and this was because the 8 here is greater than 5. Another example, round 64.3463 to 3 decimal places. So the solution, so to round up to 3 decimal places, it implies that you leave 3 numbers after the decimal point. So if you start counting here, 1, this is the decimal point, so this is the first number after it, the second number, and the third number. So you want the number to stop here, so the next thing you do is to consider the next digit after the third decimal place. So you have 3, and if you remember from the illustration, 3 is in the range 0, 1, 2, 3, 4, so it's less than 5, so which means you ignore 3 and you leave the number 64.346. So you have the answer to be 64.346. Another example, round 128.35 to 1 decimal place. So the solution, it means you should after rounding it, expressing the number to a number in 1 decimal place with 1 decimal place, you only have 1 number after the decimal point. So now the number is 3, so the next number is 5, and since 5 is greater than 4, so all you do is just round the 3 here up by 1, so you have 128.4. so that is the answer. So you have to know that all the explanations so far is to make you understand the concept, the underlying principles of arithmetic operations on decimals. In the JAMB examination hall, you will be provided with a calculator before the commencement of the exam. But when you understand the concept clearly, so while working in doing your JAMB examination, you could easily detect the mistakes when you make mistakes. But if you don't really get the concept, or even when you press the wrong value on your calculator, you might not be able to detect that you have a wrong answer. So that is the reason why we've gone through the underlying principles of the arithmetic operations on decimals. So now let's have some sample questions. Convert 3.1415926 to 5 decimal places. So this question is from UME 1995. So the score booster solution is 3.1415926. So it's simply the question that has been written. So now to 5 decimal places, it means you have 5 numbers after the decimal point. So you have 1, 2, 3, 4, 5. So that means you have to stop. This is the last digit needed in the rounded form. So you now look at the next number, which is 2, and since 2 is less than 5, so you simply ignore the 2 and 6, and you have 3.14159. so expressing this number here to 5 decimal places, you have 3.14159. Another example, simplify 52.4 minus 5.7 minus 3.45 minus 1.75. This question is from UME 2002, and the solution is this question has been rewritten here. So now, since minus 1 is common to the 3 numbers here, you could simply factorize to make the solution, the simplification easy. So when you bring out factorize out minus 1, so you just you have add plus here, because, and if you want to confirm, you can simply expand back. So when you have minus 5.7 plus times minus, you have minus, and you have minus 3.45, and the same here, you have minus 1.75. so when you bring out minus 1, so the signs here will become plus. So now, since we have the terms in brackets here, so we now simplify, because according to BODMAS, you simplify the expression in the bracket first. So now, simplifying the expression in bracket, we could simply align the numbers, the decimal numbers, using their decimal points. So you then add 5 plus 5, you have 10. So you write the 0, you keep the 1, and when you add 4 to 7, when you add 7 to 4, you have 11, then plus 7, making 18. Then you add the 1 that you lifted over from here, so you have 19. So you have 9, you write the 9, then you keep 1. So when you now add 5 plus 3 plus 1, you have 9, then you now add the 1, so you have 9 plus 1 making 10, so you have 10.90. so now you can then replace the expression in brackets here with 10.90. so by so doing, aligning the two numbers using their decimal points, so 0 minus 0, 0 minus 0, you have 0, and you have here 9 is greater than 4. So all you have to do is you lift 1 from 2 here, so to make it 51, and here you have it as 14, because when you bring 1 here over the through decimal point to when you add it to 4, you have 10. And to make it clear, so when you have 1 divided by 0.1, so you have 10. So when you lift when you deduct 1 from 52 here, you have 51. So when you bring the 1 here, so you have it as 10, because 1 unit here is equivalent to 10 at this position. So you have 14. So 9 minus 14, you have 5, and here it remains 51. So 51 minus 10, you have 41. So let's look at another sample question. Evaluate 21.05347 minus 1.6324 times 0.43 to 3 decimal places. This question is from UME 2001, and here is the solution. So now, from the principle of BODMAS, which implies bracket of division, multiplication, addition, subtraction. So this is the sequence of simplifying numbers arithmetic operations on numbers. So the bracket comes first, and we have no bracket, we have no off, so the next thing, division, we do not have. So multiplication is the next, and we have multiplication, so we have to multiply 1.6324 and 0.43. so when you multiply the two, you have 0.701932. you can use a calculator, and so you now replace the expression here with 0.701932. so when you replace it, you have 21.05347 minus 0.701932. so when you deduct the two using your calculator, you have 20.351538. and expressing 3 decimal places, so this is the last digit in the 3rd decimal place, so the next digit is 5, so it's greater than 4, so you add you round this one up by 2, so you have 20.352, 3 decimal places. So you can have a look at these practice questions on your own before going through the ScoreBooster solutions. So let's have a look at the solutions to the practice questions. So question 1, evaluate 1.25 times 0.025 times 0.005 correct to 1 decimal place. This question is from UTME 2013. So the solution. So 1.25 is simply 125 times 10 raised power minus 2. So 125 is 1.25 times 100. So 10 raised power minus 2 is 1 over 100. So when you multiply together, you still have 1.25. So times here 0.025 is 25 over 1000. So when you multiply by 1000 here, you get 25. And when you divide by 1000 back, you have this. So we've not actually done anything, it's just simply expressing the numbers in their standard forms. So divided by 0.005 is 5 times 10 raised power minus 3. So we have 125 times 25 times 10 raised power minus 5 divided by 5 times 10 raised power minus 3. So now 5 divided by 5, you have 1, and 5 divided by 25, you have 5. So 125 times 5 is 625. Then 10 raised power minus 5 divided by 10 raised power minus 3 is simply 10 raised power minus 5 minus 3, which is 10 raised power minus 5 plus 3 equals 10 raised power minus 2. So according to law of indices, so you have 625 times 10 raised power minus 2, which is 6.25. So second question, simplify 0.00 the square root of 0.0023 times 750 divided by 0.00345 times 1.25. This question is from UTME 1990. Yeah, it's from UME 1999. So the solution is simply the question has been rewritten. Then 0.0023 is simply 23 times 10 raised to power minus 4. So then 750 remains, and also here 0.00345 is simply 345 times 10 raised to power minus 5, and 1.125 here is 1.25 times 10 raised to power minus 2. So 10 raised to power minus 5 from here, and 10 with 10 raised to power minus 2 from here, so we have 10 raised to power minus 7, because when you have the same base and when you are multiplied numbers with the same base, then you add their indices. So minus 5 minus 2 is minus 7. So then we can now simplify further. 125 in 125 you have 1, and 125 in 750 you have 6, and also 23 in 23 you have 1, and 23 in 345 you have 15 of it. So we have 6 over 15. Then 10 raised to power minus 4 divided by 10 raised to power minus 7. So according to the law of indices, since the bases are the same, you simply have 10 raised to power minus 4 divided by 10 raised to power minus 7 is simply 10 raised to power minus 4 minus 7, so which is 10 raised to power minus 10 raised to power minus 4 plus 7, since minus times minus is plus. So we have 10 raised to power minus 4 then minus 7. So minus times minus, you have plus, then minus 10, you have 10 raised to power minus 4 plus 7. So minus 4 plus 7 is 3, so we have 10 raised to power 3. So now we can simplify 6 over 15 further, because it has not been expressed in its simplest form. We still have you can use the highest common factor, which is 3. So 3 in 6 you have 2, and 3 in 15 you have 5. So we have 2 over 5 times 10 raised to power minus 3. So 10 raised to power times 10 raised to power 3, sorry. So 10 raised to power 3 is 1000, and 5 in 1000 you have 1, and 5 in 1000 you have 200. So we have the square root of 2 times 200, which is the square root of 400. So, and the square root of 400 is 20. So your answer is 20. So the third practice question: find 1 over 0.0006 divided by 1 over 0.042 all raised to power minus 1, and correct the answer to 2 decimal places. The question is from UME 2003, and the solution. So this is the question. So in order to from according to board mass, if you remember, division comes first. So we simply change division to a multiplication sign, and when we do that, we have to take the inverse of this. So 1 over 0.042 is 0.042 divided by 1. Is simply replacing the numerator with the denominator and the denominator with the numerator. So we have 0.042 over 1. So once we've replaced division by times, so we have this as this, and then all raised to power minus 1. So 0.042 divided by 0.06 all raised to power minus 1. So now this is still an inverse, so we simply replace the numerator by the denominator and then the denominator with the numerator. So 0.06 divided by 0.042. So now can you see the denominator here has become the numerator here, and the numerator has been made into a denominator. So now we can now start moving the decimal point. So when you move first time, second time, you have 6.0 here, and when you move third time, you have 60. And here we've also moved 3 times, 1, 2, and 3. So we've moved the same place, so we have 60 over 42. So and the HCF is 6. So 6 in 60 you have 10, and 6 in 42 we have 7. So we have 10 over 7, which is 1.428. And now to 2 decimal places. So 1, 2, so it stops here. And now the 8 here is greater than 5, so we simply round 2 up by 1, so we have 1.43 to 2 decimal places. And now the practice question 4: find correct to 3 decimal places. 1 over 0.05 divided by 1 over 5.005 minus 0.05 times 2.05. This question is from UME 1991, and the solution. So the expressions in brackets, you have to simplify them in accordance to board mass. So here 1 over 0.005, when you move decimal points here, both the numerator and the denominator, when you move it twice, so here is 1.0, so you simply have it as 100, 1, 2, so you have 10 here, and you have 100.0. So here when you move twice, you have 5. So as you can see, we have 100 over 5, then divided by here, when you move the decimal point 1, 2, 3 in 3 places, you have 5005, 5005, and here you have 1.0. When you move 1.000, the same thing as 1.0. So when you move decimal point in 3 places to the right, you have 1, 2, 3, and you have 1000. So you have 1000 over 5.005. So 100 over 5. Then when we place this division with multiplication, then we have to invert this. So we take the inverse of this. So we have that means we replace the numerator with the denominator and the denominator with the numerator. So we have 5005 divided by 1000. And now and here too we have the expression here in bracket. So we now have simply the zeros can cancel out. When you cancel out the 0, then 5 here, then you have 1001. You have 1001. So when you divide 1001 by 10, so you have 100.1. So then when you multiply this with a calculator, you have 0.1025. So 100.1 minus 0.1025 equals 99.9975. So you round the 7 up by 1, so you have 99.998. So correcting to 3 decimal places. So that's the answer. And the last practice question: evaluate 0.14 squared times 0.275 all over 7 times 0.02, correct to 3 decimal places. This question is from UME 2001. So the ScoreBooster solution: 0.14 squared is simply 0.14 times 0.14. Then when you multiply 0.02 times 7, so you have 0.14. So 0.14 can cancel out. Then you have 0.14 times 0.275. So when you multiply the two, you have 0.0385. So 0.0385. Then when we are to correct to 3 decimal places, then the number there should be 3 numbers after the decimal point. So since 5 here is greater than 4, so we round it up by 1, so we have 0.039, correcting to 3 decimal place. You have to know that we've counted the 0 because it's before the numbers. So when you are trying to express the number to a certain number of decimal places, when 0 is before immediately after decimal point and before numbers, or in between numbers, then you have to count the 0 when you're expressing the number to a particular number of decimal places. But if the 0 is after the numbers and there is no number after the 0, that means you may not count it. The same reason why 0.100 is equal to 0.1. So the zeros here, you might not make use of them when you try to express the number to a certain number of decimal places. So thank you for watching the video.